All right, ladies and gentlemen, this is our third part of our series on complex numbers. We're going to look at expressions that have complex solutions, or what to do with the number I. Now, as a reminder that we have actually four ways to solve for quadratics, and the first way to solve for it is to factor if you can. And if you can't factor, then step 2 is to see if you can isolate the x squared or the x minus number squared. If you can isolate that and don't have another x or something else in the problem, you can then take the square root of both sides. Step number 3 is to complete the square, but generally speaking, we're going to probably do the quadratic formula instead. So we're going to try to factor, and none of these 6 problems I'm going to give to you are factorable. So we're just going to pretty much forget about factoring on this page. The second part is to try to isolate x squared, and that's actually going to be done for 5 of these 6 problems. The other problem that isn't going to be able to be isolated, we're going to either complete the square or quadratic formula, and I'm going to choose to use the quadratic formula since most of us had more practice doing it and will actually succeed. Completing the square also has some shortfalls. For example, completing the square doesn't work very well if the middle number is negative. Sorry, not negative. If the middle number is an odd number. And also, completing the square doesn't work very well if the first number is not a 1. So again, factoring's out, completing the square is out, so we're going to use this pattern of either isolating the x squared or the x minus number quantity squared, or we're going to use the quadratic formula. Also, as a note too, that if we take the square root of something, we have to consider the positive and negative values of it if there's an x in the problem. So in this first problem, we see that it is not factorable because this is not a difference of squares. So we're going to isolate that x squared, and if we do so, we get x squared is equal to negative 64. Take the square root of both sides, and this is going to give me x is equal to plus or minus the square root of negative 64. And what we learned in a previous video is that we can take the square root of negative 64 and break that down into the square root of 64 times the square root of negative 1. So my answer is x is equal to plus or minus the square root of 64, which is 8. The square root of negative 1 is I. And that is my answer to the problem. My answer has that plus minus because we have the square root of a variable x, and that gives us our 2 possibilities. This problem here, since it is not factorable, I'm going to try to isolate this x squared by subtracting the 539 from both sides. And that gives me here an 11x squared is equal to negative 539. Dividing both sides by 11 and just hoping to see that something comes out nice, it is, because this divided by 11 gives me negative 49. Take the square root of both sides. Now that the x squared is isolated, we now see that we have x is equal to plus or minus the square root of negative 49, which I can then split up into the square root of 49 and the square root of negative 1. So x is equal to plus or minus 7i. And that's the answer to that problem. So 2 down, 4 to go. This third problem here is not factorable. You cannot actually isolate the x squared either, since it has an x in the problem too. What unfortunately you're going to have to use is the quadratic formula. And again, completing the square could be an option, but I seriously would want you to use the quadratic formula. Just because it's a little easier. So negative b is 6 plus or minus the square root of b squared, negative 6 squared, minus 4 times 1 times c, or 4 times a times c, which is 4 times 1 times 13, all over 2 times a. In this case, it's going to be 2 times 1, which is 2. So I'm going to split this up into 6 halves, plus or minus the square root. I'm going to evaluate the discriminant, which is going to be this negative 6 squared. Make sure that's in parentheses, minus 4 times 1 times 13, and which is going to give me a negative 16 all over the 2. So this is going to be 3 plus or minus. This in the numerator becomes a 4i, because I can remove the 6 from 16 and negative 1. I can make that a product of 16 and negative 1. And the square root of 16 is 4. The square root of negative 1 is I. So this is going to give me 3 plus or minus in the numerator, 4i divided by 2. And I can simplify the 4 divided by 2, which makes the answer of 2i. And there's my answer to the problem. In the third of these 6 examples, and you'll see that, or sorry, the fourth of these 6 examples, and you see example 4, 5, and 6 all look the same kind of format-wise, we are going to subtract the 9 from both sides and have x plus 1 quantity squared is equal to negative 2. And this is going to be when I take my square root. It is possible for us to have FOILed this out and write it twice, FOIL it out, move everything to one side, and use quadratic formula, but you'll see that this problem goes pretty quickly, because as I square root both sides, I now have x plus 1 is equal to plus or minus the square root of negative 2, which I can rewrite this to be plus or minus the square root of 2i, taking the negative out of the problem, which would make it I. So, you know, again, if you're wanting to see how that worked, the square root of negative 2 is the same as the square root of 2 times the square root of negative 1. The square root of negative 1 is I. So the square root of 2i is just moved here. Well, I'm going to have to move that 1 over. I'm going to subtract 1 from both sides, and that 1 is going to go in front because we like to write our rationals in front, then our irrationals, then our imaginary numbers there. And that's the answer to the fourth problem. 2 more problems to go. So here they are. Click. Okay. So we're going to move the 36 to the other side because we can isolate then the x plus 1 quantity squared for prep to do the square root. And whoa, 36. Yikes. There you go. And then we're going to take the square root of both sides. So we got x plus 1 is equal to plus or minus the square root of negative 36, which is another way of saying plus or minus the square root of 6i, because the square root of negative 36 is the same as saying the square root of 36 times the square root of negative 1. If I, well, I almost wrote a plus 1 there. If I subtract 1 from both sides, here I have an answer of x is equal to negative 1 plus or minus square root, or sorry, plus or minus 6i, and that's my answer there. One more answer, same kind of pattern, subtract the 25 from both sides, and this is so much better than foiling this out and using the quadratic formula. And that gives me x minus 5 quantity squared is equal to negative 25. I'm going to take the square root of both sides, and so this gives me x minus 5. And I'm going to work faster here. This is going to give me plus or minus 5i. And that's because the square root of 25 is 5, the square root of negative 1 is I. And if I add the 5 to both sides, again, please don't combine this here because that is a 5 and that's a 5 imaginary, 5i. X is equal to 5 plus or minus 5i, and that is our answer for the last problem. So there's our 6 examples of solving expressions with complex solutions. Thank you for watching.